Welcome to my channel. This video we will continue our chapter Real Numbers, the fundamental theorem of arithmetics. In my last video I have explained what is fundamental theorem of arithmetics. Here we will do the exercise number 1.2 from CBSE NCERT textbook. Exercise number 1.2. First question, express each number as a product of its prime factors. The first number is number 140. For this we need to prime factorize 140. If we prime factorize 140, we will get 140 is equal to 2 multiplied by 2 multiplied by 5 multiplied by 7 and multiplied by 1, which we can write as 2 to the power of 2 multiplied by 5 multiplied by 7. So if we express 140 as a product of its prime factors, we can say 140 is equal to 2 to the power of 2 multiplied by 5 multiplied by 7. The second number is number 156. In the same way, if we factorize 156, we will get 156 is equal to 2 multiplied by 2 multiplied by 13 multiplied by 3 and multiplied by 1, which can be written as 2 to the power of 2 multiplied by 13 multiplied by 3. So we can express 156 as the product of its prime factors as 2 to the power of 2 multiplied by 13 and multiplied by 3. The third number is 3825. When we prime factorize 3825, we will get 3 multiplied by 3 multiplied by 5 multiplied by 5 multiplied by 17 and multiplied by 1. Hence we can express 3825 as a product of its prime factors in the form 3 to the power of 2 multiplied by 5 to the power of 2 and multiplied by 17. The fourth number is 5005. After prime factorizing 5005, we will get 5 multiplied by 17 multiplied by 11 into 13 multiplied by 1. So we can express 5005 as 5 multiplied by 7 multiplied by 11 and multiplied by 13. The last number here is 7429. When we prime factorize 7429, we will get 17 multiplied by 19 multiplied by 23 multiplied by 1, which can be expressed as 17 multiplied by 19 multiplied by 23. Now the second question, find the LCM and HCF of the following pairs of integers and verify that LCM multiplied by HCF is equal to the product of the two numbers. The first set of numbers are 26 and 91. So we have studied that the product of two numbers is equal to the product of their LCM and HCF. For that, first we need to express these numbers as the product of its prime factors. So for 26, if we factorize, we can express 26 as 2 multiplied by 13 multiplied by 1, and 91 can be expressed as 7 multiplied by 13 multiplied by 1. Therefore, LCM of 26 and 91, the greatest power of all the factors involved, which is 2, 7, 13 and 1. If we take the product of these numbers, we will get 182. And the highest common factor of 26 and 91, we can see there is two common factors, which is 13 and 1, and the highest one is number 13. Now let's verify the formula. The product of 26 and 91 is equal to 2366, and the product of LCM and HCF, which is 182 multiplied by 13, will give you also 2366. Hence we can prove that the product of the LCM and HCF of two numbers are equal to the product of the given numbers. Now the second set of numbers are 510 and 92. In the same way, let's express 510 and 92 as the product of its prime factors. We will get 510 if we express as the product of prime factors, we can say 2 multiplied by 3 multiplied by 17 multiplied by 5 multiplied by 1. And 92 can be expressed as 2 multiplied by 2 multiplied by 23 and multiplied by 1. And here for LCM, if we can take the greatest power of all the factors involved, which is 2 multiplied by 2 multiplied by 3 multiplied by 5 multiplied by 17 and multiplied by 23, which is equal to 23,460. And highest common factor for these two numbers, we can see there is only one common factor. There is two common factors, which is 1 and 2 again, and the highest one is number 2. Let's verify the formula. The product of 510 and 92 will give you 46,920, and the product of their LCM and HCF will also give you 46,920. Hence, we prove the formula LCM of and the product of the LCM and HCF of two numbers is equal to the product of the numbers. Now, the third set numbers is 336 and 54. In the same way, let's express these numbers as the product of its prime factors. For 336, we will get as 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 7 multiplied by 3 and multiplied by 1. 54 can be expressed as 2 multiplied by 3 multiplied by 3 multiplied by 3 and multiplied by 1. I am not showing the prime factorization here because we have seen that in the previous classes and also previous videos, which is very familiar to you. So here the LCM, we can take the highest power of each factors involved, which is for 2 to the power of 4 times 7 times 3 to the power of 3 and multiplied by 1, which will give you 3024. And HCF of these two numbers are, there is two common factors. We can see 2 and 3. So both of them are common factors, and the HCF is 2 multiplied by 3, which is 6. Now let's verify the same formula. The product of these two numbers, which is 336 multiplied by 54, is equal to 18,144, and product of their LCM and HCF is equal to 3024 times 6, which is also equal to 18,144. Let's move to the third question. Find the LCM and HCF of the following integers by applying the prime factorization method. The first set of numbers are 12, 15 and 21. Writing the product of prime factors for all the three numbers, we will get 12 can be expressed as 2 multiplied by 2 multiplied by 3, and 15 can be expressed as 5 multiplied by 3, and 21 can be expressed as 7 multiplied by 3. Therefore, the HCF of 12, 15 and 21 is 3. We can see 3 is the common factor. So the HCF for 12, 15, 21 is number 3, and the LCM for 12, 15, 21 is the highest power of all the factors involved. So here we can see 2 is the 2 to the power of 2, which can be 2 multiplied by 2 multiplied by 3 multiplied by 5 and multiplied by 7, which will give you 420. So the HCF is 33 and LCM is 420. Now the second set of numbers, which is 17, 23 and 29. Same way, if we write the product of prime factors for all the three numbers, we will get 17 is also a prime number. So there is only two factors, which is 17 and 1, and 23 is another prime number. 23 and 1 are the factors for 23, and 29 is also a prime number. So the factors are 29 and 1. Therefore, the highest common factor of 17, 23, 29 is equal to 1, and the lowest common factor for 17, 23, 29 is equal to the product of all the factors involved, which is 17 multiplied by 23 multiplied by 29, which will give you 11,339. So the HCF is 1 and the LCM is 11,339. Next question is, given that HCF of two numbers, which is 306 and 657 is 9. The HCF of two numbers 306 and 657 is 9. Find the LCM of these two numbers. So solution, as we know, HCF multiplied by LCM is equal to product of the two given numbers. So if we replace the value in the formula, we can write it as 9 multiplied, which is the HCF of these two numbers, multiplied by the LCM which we need to find out. is equal to 306 multiplied by 657. If we replace the equation, if we rewrite the equation, we can bring 9 this side. So 306 multiplied by 657 divided by 9 will give you 22,338, which is the LCM of 306 and 657. Now the fifth question. Check whether 6 to the power of n can end with the digit 0 for any natural number n. Given any natural number n, we need to see whether 6 to the power n can end with the digit 0. We all know the divisibility rules of all the numbers. For any number with the unit place as 0 and 5, it is divisible by 5. So if the number 6 to the power n ends with the digit 0, then it should be divisible by 5. If you prime factorize 6 to the power of n, we can write 2 multiplied by 3 to the power of n. So here the prime factorization of 6 to the power of n doesn't contain the prime number 5. So it is clear that for any natural number n, 6 to the power n is not divisible by 5. And thus it proves that 6 to the power n cannot end with the digit 0 for any natural number n. This is based on the divisibility rule of number 5. Any number which ends with the unit place as 0 and 5 needs to be divisible by 5. And we can see the prime factors of 6 doesn't have the prime number 5 as its factor. So we can conclude that any number with any natural number n, 6 to the power of n cannot end with the digit 0. Question number 6. Explain why 7 multiplied by 11 multiplied by 13 plus 13 and 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 plus 5 are composite numbers. So here we have given two set of numbers, two set of expressions of a number, and we need to prove whether they are composite numbers. As a composite number, we know the numbers which have more than two factors are called composite numbers. The numbers which have more than two factors are called composite numbers. So we can write the given expression 7 multiplied by 11 multiplied by 13 plus 13. Taking 13 as a common factor, we can write it as 13 multiplied by 7 multiplied by 11 multiplied by 1 plus 1, which can be simplified to 13 multiplied by 77 plus 1, which is equal to 13 multiplied by 78. If we prime factorize 78, 78 can be expressed as the product of 3 multiplied by 2 multiplied by 13. Hence, we can see there is more than two factors involved for this expression. The factors involved are 13, 3, 2 and 1. So, any number with more than two factors are composite number. Hence, we can say the given expression is a composite number. Now, let's take the other expression, which is 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 plus 5. In the same way as we did in the previous question, take 5 as a common factor and we will get 5 multiplied by 7 into 6 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1 plus 1, which is equal to 5 multiplied by 1008 plus 1, which is equal to 5 multiplied by 1009. We know if we prime factorize 1009, we will get many factors. It has more than two factors. Hence, we can say this expression is also a composite number because it has more than two factors. Now, the last question from the exercise. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. after how many minutes will they meet again at the starting point? Here, the method to find the time when they will be meeting again is to find the LCM of 18 and 12. We can see both Sonia and Ravi is moving in the same direction and they have started at the same time and also from the same point. So if we can find the LCM of 18 and 12, that is the meeting time, the next meeting time of both Ravi and Sonia. The LCM of 18 and 12 we know, which is number 36. So hence we can say Sonia and Ravi will meet again at the starting point after 36 minutes. Let me explain this once again so if Sonia is taking 18 minutes to drive one round of field, Sonia's second round will finish in 36 minutes. But Ravi is only taking 12 minutes for same round, same field. So for Ravi, it will take it in 36 minutes. Ravi will finish the 3 rounds. So as the common multiple of 18 and 12, the lowest common multiple is 36. So in 36 minutes, they will meet again at the starting point. I hope you are clear with the idea and the principle behind the fundamental theorem of arithmetic. Please like, share and subscribe and click the bell icon so you will not miss my next video. Thank you for watching.